Hi everyone, welcome back to another Algebra 1 tutorial. In this tutorial, we'll be going over the basics of inequalities and solving them. So what is an inequality? An inequality is a statement that two quantities are not equal. There are 5 different signs representing inequalities. The first, there's a greater than sign, which basically states that one quantity is greater than another. Then there's a less than sign, which states that one quantity is less than another. So A is greater than B or A is less than B. Then there's the less than or equal to sign, which is for stating that A can be less than or equal to B. So A can either, so suppose B is 6, then A can be 6 or less. And similarly for the greater than or equal to sign, A can be either equal to 6 or greater than 6. And then finally there's a not equal to sign, which is to state that two quantities are not at all equal to each other. So we're going to be mainly using the greater than, less than, greater than or equal to, and less than or equal to signs the most in this chapter. So for graphing inequalities, we would graph it in a number line. So suppose for this one, x is greater than 5 in the number line. Suppose this is 5, then we would graph it like this with an open dot. However, whenever it asks for greater than or equal to, we would graph it with a closed dot. So let's do x is greater than or equal to 7, and then let's just say 7 is here. Then we would just put a closed dot, and then we would write a line like this. And one thing you have to notice is that for these greater than or equal to symbols, and for the greater than, all of them have an arrow at the end, showing that there's an infinite number of values on that end, which can be a value for x. So there are 4 different ways of solving inequalities. You can solve them by addition. So for example, we have x minus 6 is greater than 5. For this one, we would just add 6 on both sides to get x is greater than 11, and that would be our answer. So there is a property for solving inequalities by addition. So if A is greater than C, then A plus B is greater than C plus B. And whatever you add to either side, it will still hold true. So similar to the way you solve it by addition, you can solve it to subtraction. So suppose we have A is less than B, then we can do A is minus C is less than B minus C, and this equation will still hold true, or inequality. However, for multiplication, it works a little differently. So suppose you have A is greater than B. So when you multiply it by the same positive number, so AC is greater than BC, the inequality would still hold true with the greater than sign. However, when you multiply it with a negative number, so for example we have A is greater than B, but then suppose instead you do negative CA is greater than negative CB, so basically you're multiplying negative C on both sides. This time, instead of this would not be right because you're multiplying it by a negative number. Instead, you would get negative CA is less than negative CB. So the inequality sign flips. And the same works for division. So if you divide by a positive number, so A by C greater than B by C, this would still hold true. However, when you're dividing by a negative number, so A by negative C is greater than B by negative C, would not hold true. And instead it would be A by negative C is less than B by negative C. So now let's solve a few problems. So 4 plus x is greater than 9. So we could subtract 4 from both sides to get x is greater than 5, and that would be our answer. And if we were told to graph it, we'll graph it like such. And this would be our graph. Let's solve this one. So x minus 4 times 4 is greater than or equal to 20. So for solving this one, we have to remember BODMAS. So x, and then we'd have to multiply these first. So negative 4 times 4 would be minus 16, greater than or equal to 20. And then all we need to do is add 16 to both sides to get x minus 16 plus 16, greater than or equal to 20 plus 16. And then we would get x is greater than or equal to 36. And that would be our solution. And we could graph this like so. So remembering the closed dot and open dot. So let's do this one. So b plus 5 over 9 is less than or equal to 5. So for this one first, we would multiply 9 on both sides. So b plus 5 over 9 all times 9 is less than or equal to 5 times 9. So we'd cancel out the 9s. So b plus 5 is less than or equal to 45. And then we would get b plus 5 minus 5 is less than or equal to 45 minus 5. And we get b is less than or equal to 40. And that would be a solution. And we will graph it like so. So a note, all the properties shown above, so division, multiplication, subtraction, and addition, all of the properties apply to all inequality symbols. Okay, now let's solve for more complex inequalities. So let's solve for multi-step inequalities. So similar to normal inequalities, a multi-step inequality also requires you to solve for a variable, whereas this time it requires you to solve for it using multiple steps. For example, we have 3x minus 5 is greater than 7. So to solve for this, all we need to do is 3x minus 5 plus 5 is greater than 7 plus 5. And we get 3x is greater than 12. And then we get x is greater, we get 3x over 3 is greater than 12 over 3, which would simplify to x is greater than 4, which would be our solution. And we could graph this to get that as a graph. Solving inequalities with variables on both sides. So to solve such inequalities, we would use the same properties. So suppose we have this one. To solve this one, all we need to do is subtract 2x to get x minus 7 is greater than 3, and then we could just add 7 to both sides to get x is greater than 10, and that would be our solution. And we graph it in a similar way. So 10. And yeah, so that's all for this video. I hope this helped you with inequalities, solving for inequalities, and I hope I see you next time. Bye.